Next topic is row space, column space, and null space of a matrix. So, what is row vectors of this matrix? This matrix is 3, 5, 7, 1, 2, 4, 0, 6, 8. So, this 3, 5, 7, write in a square bracket or write in round bracket. That is open bracket. 3 comma 5 comma 7, that is as a first row as a write as a vector, then write second row as a vector 1 2 4, 1 comma 2 comma 4, and the third row as a third vector 0 6 8, right, either open bracket or close bracket. So these are the three, actually these are the three rows of this matrix, and A, and these are called row vectors of matrix. And if we form the columns as a vector, that is first column as a first vector, right, either in this bracket again square bracket or open bracket, okay, close bracket or open bracket, that is round bracket. So 3 1 0, that is prepare the uh, vectors of first column as a first vector, second column as a vector, third column as a vector, and these are called column vectors of the matrix A. So these are the rows vector and these are the column vectors. So for m by n order matrix, if we form the row as a vector, then these are the m rows of these m row vectors, and these are the columns. If we form each column as a vector, then these are the column vectors of the matrix A. Okay, so row vector and column vector. Now definition: if A is m by n matrix, then subspace of R raised to n spanned by the row vectors of A is denoted by row A, ROW in bracket A, or is called row space of A, and is called row space of A. That is the vector space spanned by vectors of A is called row vector, row space of the matrix A, and is denoted by ROW A. That is the row space of matrix A. That is the vectors, that is the subspace or vector space spanned by the row vectors of A is called row space, and the subspace or vector space spanned by column vectors of matrix A is denoted by columns, is denoted by this COLA, that is a column space of matrix A. So column space means a vector space spanned by the column vectors of the matrix A. And the solution space of homogeneous system Ax is equal to 0, which is subspace of R(n) and is denoted by NuLLA, that is, and is called null space of A, denoted by NuLLA, and is called null space of A. So what is the null space of A? Is solution space of the system Ax is equal to 0. Okay, so this is the null space, the solution space of system Ax is equal to 0, and dimension of null space of A is called nullity of A. That is the this is null space of A is the vector space, and so its dimension of null space is called nullity of A. What is the dimension of null space of A? The number of elements in its basis is called nullity of A, NuLLity in bracket A, nullity of A, the matrix, nullity of matrix A. And the dimension of row space of A is called rank of A, or the dimension of column space of A is also called rank of A. It means that the for any matrix A, dimension of row space of A and dimension of column space of A both are same, obviously, and this number is called rank of the matrix A. That is, in order to find rank of A, we have to find either dimension of row space of matrix A or dimension of column space of matrix A. So the dimension of row space of A or column space of A both are same and is called rank of the matrix. Okay, and the nullity of the matrix is the dimension of null space of A. So these are the definition. If A and B are two matrices, if one matrix B can be obtained applying successive elementary row operations on A, that is applying the row operations on A. If we have the matrix B, then we say A and B are equivalent matrices, row equivalent matrices. A and B are called row equivalent matrices, and denoted by this notation: A, right wiggle, R at the top of this wiggle, B means A is equivalent to B, row equivalent to B. So a matrix A is a row equivalent form, then its non-zero rows form a basis of row space of A. So this remark gives the procedure to how to obtain the basis of row space of matrix A. So how we can obtain the row space basis of row space of matrix A? If a matrix is in echelon form, then its non-zero rows form a basis for a row space of matrix A. That is, reduce the matrix A to echelon form, row echelon form or echelon form, one and the same. Then the number of non-zero rows form the basis for a row space of matrix. That is, uh, form the each row as a one vector, non-zero row as a one vector, and that set is the basis of row space of A. So this remark 3.3 gives the procedure how to find the basis for row space of A, and the number of elements in the basis of row space of A is called rank of A. So this remark 3.3 gives the procedure how we can find a basis and dimension of row space of matrix A, and that is the rank of the matrix A. And in order to find the basis and dimension of a column space of matrix A, use this theorem, that if a matrix is in a reduced row echelon form, then the column vectors that contains leading ones form a basis for column space of the matrix. Okay, so if the matrix is in a reduced row echelon form, then the column vectors that contains leading one form the basis for column space of the matrix, and the corresponding columns in A form the uh, uh, form the basis for matrix A. That is, in order to find the basis for column space of matrix A, first reduce matrix A to reduced row echelon form and denote note the columns that contains leading one, and the suppose one column number 1, 3 and 4 contains leading one, then the corresponding columns in the matrix A, that is number 1, 3 and 4, these three columns forms the basis for column space of matrix A. So this theorem 3.5 gives the procedure how we can find the uh, basis for column space of matrix A, and dimension of column space of A is also called rank of A. So these two remark gives the procedure how we can find the basis for column space and row space. That is, this procedure gives the this two remark and 3.5 theorem gives the procedure how we can find rank of the matrix. And null space of the system, null space of A is the solution space of the system X is equal to 0. So this remark gives the how we can find the nullity of the matrix, okay, or null space of the matrix. Okay, so the we have to find the solution of the system X is equal to 0. So we will solve some examples to explain this. So again, this is the definition of rank and nullity. So nullity of A is denoted by NULLA. It is called null space of A. Actually, null space of A. NULLA is null space of A, and the nullity of A is denoted by this NULL, capital NULL. A means nullity of A or null space of A. Nullity of A. And what is nullity? Nullity is the dimension of solution space of the system X is equal to 0. So rank of A is the dimension of row space of A is equal to dimension of column space of A, dimension of range space of A. Don't use this sentence. Use this sentence that rank of A is dimension of row space of A or dimension of column space of A. So is called rank of A. And nullity of A is the dimension of null space of A, and that is the dimension of the system Ax is equal to 0. The system Ax is equal to 0. The null space is the dimension of solution space, actually, not column space. Solution space of system X is equal to 0. Solution, right here, solution space of system X is equal to 0. So if A and B are row equivalent or column, A and B are row equivalent, then A and B have the same row rank or same column rank. Okay, so A and B are of the same rank if A and B are equivalent. row equivalent. Okay, so we have to find we have to solve this example. Determine the basis for row space of the matrix. Or the question is for determine the basis and rank of basis and dimension of row space. That is the rank of the matrix. So first matrix is of order 2 by 2. Now we have to reduce this matrix to echelon form. So the answer of the first question, we have to reduce the matrix to echelon form. So first write A matrix and then apply the operation R2 minus 2R1. So we have 0 at this place, 0 at this place, and plus 2 again, minus 4 and plus 4 is 0. So the second row also becomes 0, and this is the echelon form. And so the basis, the non-zero rows, there is only one non-zero row, 1 2, this 1 2, right? It has a vector in round bracket 1 comma 2, and this is what, this is basis for row space of A. So basis for row space of A is equal to, right, in curly bracket, that is the set contains only one element in round bracket 1 comma 2, that is the form the 1 2 as a first one row, first row as a this non-zero rows as a one vector. And so rows, basis for row space of A is this, the set contains only one element 1 2, and therefore dimension of row space of A is 1, because this set, this basis contains only one element, and we know that the rank dimension of any vector space is the dimension, is the number of elements in its spaces. So it is this set, this basis of row space of A contains only one element, and therefore dimension of row space of A is 1, and therefore rank of A is 1. The rank of the given matrix is 1. Okay, then we have to find the answer of second question. So write first this B and then apply the operation. We have to reduce this minus 1 to plus 1. So apply the operation minus 1 minus 1 R1 first, and then apply this operation, that R2 plus 5 R1. Then we have this matrix, and then we have to reduce this minus 13 to 1. So write minus 1 by 13 R2. Then we have this. So first reduce this minus 1 to 1 and then apply R2 plus 5 R1. So we have this matrix, another matrix, at minus plus 1, minus 3, minus 9, and 0 1 3. Okay, and then we form, this is an echelon form. So this echelon form is depend on your calculation. This is not the same, this is not unique. This echelon form is not unique. That is this echelon form have some different forms. Okay, so the answer is depend, this echelon form is depend on your calculation, but the number of elements in the number of non-zero rows, this matrix contains two non-zero rows, this echelon form. So every one, if you find the echelon form, another form of echelon form, then it also contains the same number of non-zero rows, that is two non-zero rows. So this answer is unique, that this matrix contains two non-zero rows, but its forms are different. So the basis for row space of A, there are two non-zero rows. So form one first non-zero row as a one element, 1 minus 1 comma 3 comma 9, and the second non-zero rows as a second element, 0 1 3. Okay, whatever may be it. So these two vectors, it sets is a basis for row space of A, and therefore dimension of row space of A is 2, because this set contains two elements, and therefore rank of A is 2. Similarly, we have to find the rank of this basis for row space of this matrix. So write first this matrix, and then we have to reduce this matrix to echelon form. That is, we have to reduce this 2 to 0, this 2 to 0, this minus 1 to 0. So R2 minus 2 R1, R3 minus 2 R1, and R4 plus R1. So these are the operations. So after these four operations, we have this matrix. We have this matrix. Then we have to reduce this element to 0 1, but it is 0. Therefore, below element, to reduce the below element to 1. But when it is reduced to 1, if it is non-zero. But if all the elements are 0, means we have to reduce this element to 1. It is actually 1. And then we have to reduce the below two element are 0. So we have to reduce this 1 to 0 now. So R3 minus R2 is the operation. So we have this matrix. Again, we have to reduce after this, this place element is 1, but it is not it is 0 element, so we have to reduce this element to 1 and then we interchange the first this last two rows, but it is also 0, so we have to reduce this element to 1, it is actually 1. We have to reduce the below element to 0, it is actually 0, and we have to reduce lastly this is 1 but it is 0 element, so 0 element, when 0 is becomes a 1 element if we have the row below that row. So in order to reduce the element 1, don't use the above rows, we use the below rows in order to reduce the element 1. So this is an echelon form, this is an echelon form. And so this matrix contains three non-zero rows, this first non-zero row, second, third. So form the each row as a one vector. So this is the first vector r1, suppose 1 minus 1 comma minus 3 comma 4 comma minus 2 comma 5 comma 4, and the second row as the second vector 0 0 1 3 minus 2 minus 6, and the third row as a third vector. So the set of all these three vectors, so write it like this: basis for row space of A as these three vectors curly in curly bracket. Okay, and so the dimension of row space of A for this matrix C is what? The dimension of row space of A is equal to 3, and the rank of this matrix is 3. Rank of this matrix is 3. So this is C actually. So rank of C is 3. So these are the three examples of rank. So in order to find the rank, just reduce the matrix to echelon form or row echelon form, and the number of non-zero rows form the each non-zero row as a one element, and then it forms the basis of, that is the number of, that is the non-zero rows in echelon form forms the basis for a row space of that matrix. So the next example is find the basis for column space of matrix. This is the matrix. Then we have to reduce this matrix to a reduced row echelon form. So we have to reduce this element is 1. Now we have to reduce the below 2 element to 0. So the operation is what? Operation is R2 minus 2R1, R3 minus R1. And after this calculation, we have to reduce the next element to 1. Then we have to reduce the below and above element are equal to 0. After reducing this element to 1, we have to reduce above and below element are equal to 0. Then this is leading 1, this is not leading 1. And then after leading 1, we have to reduce the above element to 0. So we have, this is an reduced row echelon form of this matrix. So in between calculation, we have to write that calculation. So reduce this matrix to reduced row echelon form. So this is the reduced row echelon form of this matrix. We have the direct answer. So what are the columns that contains leading 1? So this first column contains leading 1. The second column contains leading 1. This is leading 1. And this is the third column, fourth column contains leading 1. And so if you denote by this as C1 dash, C2 dash, and C3 dash as these three vectors, or C4 dash, then these columns 1 0 0 0 1 0, right, either round bracket or square bracket. So and 0 0 1, these three forms the basis for column space of this matrix R. And we have to write the basis for column space of A. So what are that basis? The corresponding columns. So the number 1 column, corresponding column is this 1 2 1. So write 1 2 1 as one vector, and then second column as 2 1 1, and the fourth column corresponding, the fourth column contains leading 1, so corresponding fourth column is 1 1 1. So these three, that is form the set of these three, and this is the basis for column space of A. That is the basis for column space of A is what? Write in curly bracket 1 2 1 comma 2 1 1 comma 1 1 1 as a three vectors. And so write either this bracket as a round bracket or square bracket, open bracket or square bracket. So 1 2 1, write column 1 2 1, 2 1 1, and 1 1 1. So these are the columns. So this number 1 2 and fourth column contains leading 1, and so corresponding columns 1 4 1 2 and fourth columns form the basis for column space of A. This is the basis for column space of R, and you have to write the basis for column space of A. So what is the basis for column space of A? The first row first column, second column, and fourth column form the basis for column space of A. And so there are three elements, and so dimension of column space of A is 3. And so we say that rank of the matrix is 3, because dimension of column space of A is also called rank of the matrix. So find the basis for column space of matrix, this 1 2 3 1 5, 2 1 3 1 4, and then 1 1 2 1 3. That is the same matrix. 1 2 3 1 5 2 1. So we have to reduce this matrix to echelon form. Okay. So this is the simplification of this example. Then we have to reduce the, right here example, find the basis for row space, not column space, row space of matrix A. The same example, it is the basis of column space of A. So correction is here. We have to find the basis for row space of the same matrix. And we have to observe that rank dimension of column space of A and dimension of row space of A both are 3, both are same. So we have to reduce the matrix to echelon form. So write here row space, write the example, find the basis for a row space of matrix A. Then in order to find the basis for row space of matrix A, we have to reduce this matrix to echelon form. So what is the procedure? So we have to reduce these two elements to 0. So R2 minus 2 R1, R3 minus R1. We have this matrix. Then R2 3. In order to reduce this minus 3 to 1, we interchange the rows to avoid the fractional number. Instead of this, we can also apply the application. In order to reduce this minus 3 to 1, we apply the application minus 1 by 3 R2. But we have the fractional number at this place. So to avoid the fractional, and we have to reduce this minus 3 place element 1. So interchange the rows R2 3 and then multiply the second row by minus 1. We have 1 at this place without fractional numbers. And then we have to reduce this minus 3 to 0. So the application is R3 plus 3 R2. So we have 0 0 at this place, minus 1 1. And we have to reduce this minus 1 to plus 1. So minus 1 by R3, minus 1 into R3. We have this. So this is an echelon form. So if you have to reduce this matrix to reduce to echelon form, then after this is leading 1 and this is leading 1. So we have to reduce this 2 also to 0 and this 1 also to 0. So reduce this 2 to 0 and then this 1 to 0 by using this 1. Then we say that this matrix is in echelon form, reduced to echelon form. So this is the reduced to echelon form actually of this matrix. This is a row echelon form, or it's called just echelon form. And this is the reduced row echelon form. So what is the difference between a row echelon form and reduced row echelon form? There is just one difference, that in the reduced row echelon form, that the columns that contains leading 1 are that is the elements in the columns that contains leading 1 are 0 except that 1. So except this 1, all the remaining elements in this first column are 0. Except this 1, remaining element are 0. And this fourth column contains leading 1. So except this 1, all the remaining elements in this column, fourth column, are 0. And this is just in a row echelon form. And so what is basis for row space of A? Form the there are 3 rows. So form the 3 vectors from 3 rows. So 1 2 3 1 5 as first vector. Second vector 0, 1, 1, 0, 2. The third vector 0 0 0 1 0. And this is the basis for row space of A. And this dimension of row space of A is 3 and rank of A is 3. So in this example, we have tallied that the dimension of row space of A and the dimension of column space of A both are 3, both are same. And rank of E is called rank of A. So find the basis for subspace of R(5) spanned by these 4 vectors. So the vectors, the subspace spanned by this vector is nothing but the row space of this matrix A. That is this first vector as a first row, the second vector as a second row, this third vector as a third row and this as a fourth row and form the matrix suppose A. And now we have to find the basis for subspace of R raised to 5 spanned by these four vectors. So basis for subspace spanned by these four vector is the basis for row space of this matrix A. So the subspace spanned by these vectors, these four vectors, is the row space of the matrix this. So in order to find a basis for subspace of these spanned by these vectors, so we have to find the row space of this matrix A. So this is the one example which is depend on the find the basis for subspace or vector space spanned by these four vectors or five vectors, three vectors. In order to find basis for space spanned by the four vectors, three vectors, you have to find the basis for row space of the matrix. What is that matrix? That is the form the matrix A as a these vectors as its rows. Okay, and then we have to find the basis for row space of A. So in order to find the basis for row space of A, we have to reduce this matrix to echelon form. So R2 minus 2R1 and R4 minus 2R1. We have to reduce this two element to 0. Then we have this matrix. Then we have to reduce this minus 1 to plus 1. So minus 1 R2. Then next on next step we apply this application. We have to reduce this 5 and 10 to 0. So R3 minus 5R1 and R4 minus 10R1. After that, this application. So do one more step. We have this matrix, and then interchange the rows in order to reduce this. The 0 is we have to reduce this element to 1, but it is 0. So we have to reduce this minus 12 to 1, and then we have to interchange the third row and fourth row. But if at the place of minus 12 is 0, also 0, then we have to reduce this element to 1. Okay. So but here it is non-zero element, so interchange the rows, third row and fourth row, and divide by minus 12 or multiply by minus 1 by 12. We have this, and this is an echelon form. This is an echelon form, row echelon form. And so the basis for row space of A, that is the basis for space spanned by or generated by the given vectors. The basis for space spanned by these four vectors is equal to actually we have to write the basis for row space of A, and we know that the basis for row space of A is the set of non-zero rows. So the set, write curly bracket, in curly bracket the first row as the first vector, in round bracket 1 comma 2 comma 0 comma 3, the second vector second row as a second vector 0 1 3 2, and the third vector as a third row as a third vector comma 0 comma 0 comma 1 comma 1 comma 0. So these three this is the set of non-zero rows, and this is what basis for row space of A actually, and this is the basis for a space or subspace generated by or spanned by the given four vectors. So this problem is nothing but the problem of a basis for row space. That is, basis for subspace spanned by the vectors is nothing but the basis for row space of the matrix. So we'll see this problem, remaining problem, in the next lecture. That is basis for null space of matrix A.